All right, so let's talk about the first parts of chapter 2 on climate and contrast climate and weather. The weather essentially consists of the current atmospheric conditions, in particular as it pertains to the temperature of the air and precipitation, whether or not it's raining. Um, and in regards to the atmosphere, it also refers to the degree to which it's moving around, or essentially the wind that's occurring. So the weather is what's happening outside in the atmosphere at the current moment. Um, Climate is the weather pattern essentially over the year or throughout the seasons. Is it warm year round? Does the temperature change throughout the year? Does it rain the same amount throughout the year, or is there a distinct wet or dry season? Climate is something that you generally can predict. We can know, for example, this summer, July or August, it's going to be warm. That's a good prediction. Now, whether it's going to rain on a particular day, what the weather will be on August 15th, we really can't predict that. We know it'll be warm, most likely, but whether or not it'll rain, we don't know. The actual weather is something that you really can only predict, say, 10 to 14 days out. And the further you go out, of course, the less accurate your prediction will be. Can the climate change in a region? Yes, generally very slowly. For example, if we were to go back 12,000 years here in Middle Tennessee, um, this was during the last ice age, and the climate would have been a lot cooler then. It would have been more like what it is in the middle of Canada. Um, the climate and when it changes, of course, can affect organisms. If you have a relatively cool climate or a time of the year when it's cool, for example, that means animals will tend to have thicker fur. They may migrate south. They may hibernate. Plants will, at least some of them, will drop their leaves. Um, these are all adaptations for a cool climate, a cool time of the year. Whereas if you go to the tropics, you would generally not see these things, although if you were in a tropical region that has a dry season, you can have a situation where trees will drop their leaves then because of the dry conditions, not because of temperature. Climate can make short-term or have short-term changes, in particular with precipitation. So you can essentially have a drought. And here are some images from New Mexico, this drought that occurred in the early 2000s. Um, In particular, it was severe enough that the pinyon pines, these trees in the area, many of them died off. You can see these gray things down here are these dead pinyon pine trees. Now, presumably, once the rains returned, there were probably seeds in the soil and new trees would have sprouted and the forest would come back. Seasonality, that's the changes that occur in temperature and precipitation throughout the year, and this can vary to the degree that, say, around here, of course, we have variations in temperature from winter to summer. Our precipitation changes somewhat, not a whole lot, but we do have some times of the year, in particular October, that tend to be drier than other times of the year. Some places have really severe seasonality where you can have many months of the year it doesn't rain at all and other months of the year where it rains a lot. Um, Now, energy is important for natural systems, and in particular, sunlight energy is really important because it's what drives natural systems. Um, the sunlight, the light that's coming from the sun is essentially consists of what we call the electromagnetic spectrum that includes, well, other things, visible light, the light we can see, ultraviolet light, X-rays, and gamma rays. Um, What's reflected and absorbed by the atmosphere are all of the X-rays and gamma rays, a lot of the UV rays, and what mostly gets through is visible light and a little bit of UV light. Of the stuff that gets through, some of it is reflected at the Earth's surface by bright surfaces like snow and ice. Um, but you can see a good chunk of what gets through is absorbed by the Earth's surface. And of the incoming solar light, you can see about half of it does get through to the Earth's surface and is absorbed. Now, of course, some of that sunlight is used by plants in the process of photosynthesis. Um, but ultimately, all of the sunlight that's absorbed by the Earth's surface is going to be converted into heat one way or the other. Some of it just hits a dark surface and is converted into heat. Others is used by animals in metabolism, converted into heat. Um, and um, some is released into the atmosphere by plants through the process of evaporation, evapotranspiration. This is an exchange of heat that doesn't change the system, that is essentially the plants in the ground, and other is what's called sensible heat. This is heat that is exchanged from the Earth's surface into the air that changes the temperature of the Earth's surface. The Earth's surface loses heat and gives it up to the atmosphere. Um, Now, the heat that is radiated off the Earth's surface or from plants or whatever living things ultimately makes its way back out into space, but our atmosphere, in particular the greenhouse gases in the atmosphere, hold on to that heat temporarily. This is a good thing because it's what keeps the Earth's temperature warmer than the space around us. And planets like Mars that don't have much of an atmosphere, they tend to be quite cold because there's few gases to hold the heat in, and the heat rapidly escapes into outer space. Okay, so all of this sunlight coming in um, generates a lot of heat, and this has an impact on our atmosphere and our oceans, and thus on climate and weather. Um, so it's probably not too surprising that you tend to have warmer temperatures around the equator, and the question is, why is this? Well, at the equator, you are literally closer to the sun, and the equatorial regions are receiving more direct sunlight, whereas as you go further away from the equator, those areas are receiving more diffuse light. That is, the incoming light is spread over a larger part of the globe because of the sense that because of the Earth is a globe and there's sloping away as you go away from the equator. Essentially, at the equator, the sunlight hits more directly, so there is more sunlight energy hitting the Earth per unit area. This is why it's important when you travel to the tropics, to the equator, that you wear a lot of sunscreen because the sun is literally more intense there and you can burn much more quickly. Um, so when the sunlight hits the Earth's surface, it of course warms up the surface of the Earth, which warms up the air above that surface, which causes the air to rise and expand. As it rises higher up in the atmosphere, it then tends to cool down. As it cools, the water vapor in the air can condense and form clouds. Um, and so throughout time, throughout a day, you tend to get this kind of process where the surface warms, the air warms, it rises, and you tend to get cloud formation later in the day, particularly on spring and summer days when there's more intense sunlight. Um, so what this rising air does is it creates areas of low pressure. That rising air means there's less air pressure at the Earth's surface. Um, like we said, that rising air tends to result in formation of clouds and the potential for precipitation. At equatorial regions, you tend to have a lot of these low pressure systems because of all that sunlight coming in to heat up the Earth's surface. Now, this rising air just doesn't keep rising. It goes to the upper reaches of the atmosphere, and then it circles back to the north and to the south. It ultimately sinks back down, and this occurs at about 30 degrees north and south. And that creates in general high pressure systems there where the air is sinking back to the earth, creating more air pressure at the earth's surface. So when we look at a more detailed image of the earth, we see again that at the equator we tend to have these low pressure systems due to this heating effect and rising air, and you tend to get a fair amount of precipitation there. The air sinks back down at about, again, 30 degrees north and south. It has now lost a lot of its moisture at the tropics, and as it sinks down, it warms up. Warm air tends to hold on to moisture, so at 30 degrees north and south latitude, you tend to find, not all over the place, but in many areas, dry climates. Some of that air rotates north and south again. If it passes over water, it acquires moisture, it absorbs moisture through evaporation. And then at about 60 degrees north and south latitude, it rises again, creating another area of low pressure. Here we have high pressure, right, because the air is sinking. And you tend to get precipitation there as well at that low pressure zone further north. This rotating mass of air between 30 and 60 degrees is known as a Ferrel cell. And then between 60 and 90 degrees, you have the polar cell, which tends to be generally cold air with high pressure at the poles, which means you don't generally have a lot of precipitation at the poles. And of course, what you do have is mostly snow, and it doesn't melt to any degree, and so it just kind of accumulates over time, resulting in the formation of the large masses of snow and ice that we have at the North and South Pole. All right, so we can divide the Earth into some major climate zones. Around the equator, you have tropical climate, and the defining characteristic of a tropical climate is it's warm all year. You can have often wet climates, sometimes or wet tropics and sometimes dry tropics, but they're going to be warm all year round. It never freezes or even gets very cold at all. Now, at mid-latitudes, where we live, you have temperate climate where you have a warm summer and a cold winter. Okay. Now, within temperate regions, some are drier and some are wetter than others, but they always have a distinct warm and cool season or cold season. You go far enough north and south towards the pole, and you get a polar climate where it's basically cold all the time. Now, in the North Pole summer, it gets a little warmer than the North Pole's winter, but it's still pretty cold. All right, I'm going to stop there, and we'll talk about wind in the next video.